constant growth rate. This is a description that compares growth directly related to the previous population. So, example 1, you may see something that looks like this. 100% larger than last year. Okay, so example 1 is growth. Okay, this is where they tell you the percentage is your constant growth rate. That's not giving you your R though. Okay, example 2, decay. So something like 10% less. Again, this is a percentage. This isn't actually your R value. So your constant factor is your R value. So 100% larger than last year. What does that look like as a number? Not a percentage. If you start with 100% and you're going 100% more, 200%, right? Yeah. As a number is what? 2. It's been doubled. Okay? Your value is a 2. If I'm 10%, what does that look like as a number? Or as a decimal? 0.90. 10% less. That's 10 lower than 100, which is 90%. And again, as a decimal is 0.9. Okay. So where we took your 100 and subtracted off the 10 and then changed it to a decimal, that's what you just did. Okay. So your recursive formula is what we did on examples 1 and 2, where I told you P sub n is 1.1 times P sub n minus 1. You're not going to use this very often. I use to just plug in and give me numbers. This was the one that I gave you right before we left for lunch. So P sub n equals P sub 0 times R raised to the n power. Again, P sub 0 is your initial. R is your rate. Okay, your constant rate. And n represents the numbered term. Okay, what term am I looking for? And just like arithmetic, we have another one that we can use. A sub n equals A sub 1 times R times n minus 1. We're going to stick mostly with the left one.
Well, are we going to have to use the other equation on the test?
Honestly, I don't think I've ever used that one.
This one right here?
The one on the right.
Oh.
Everything I've ever done, I've used the one on the left.
Yeah, minus 1.
Okay, but the term you're looking for, your ending term, your first term, your constant rate. Okay, nothing changes here.
Only the rate?
No, your constant rate does not change. R is still your constant rate. There's nothing different about it. Question. Anybody still need this stuff?
Uh-oh.
All right, so I'm just worried about the explicit formula. Don't worry about the recursive. So P sub n equals P sub 0 always comes first. What is my P sub 0 value? 3. What's my constant rate?
3. Wait a minute.
Multiplying. 2. Everything is being doubled.
Oh, yeah,
raised to the n. You're done.
Oh, that's how we do it?
That's it.
I thought we had to solve it.
Okay. This one, P sub n. What is my initial term?
20.
20. This one's not so easy to find your growth rate. Again, we can do that by taking this number and dividing by the number before it. So what do you get when you take 24 divided by 20? You said 1.2? 1.2, so my constant growth rate is a 1.2, raised to the n. Done. That's your explicit formula. So, for instance, if I told you I wanted to find the 7th number in that sequence, you would replace n with 7 and solve.
Okay.
That's it. Okay. Finally, this last one. This is going to look like P sub n equals 400 times what? 0.75. Remember, pick a number, divide it by the number that it comes before it. This is 0.75 raised to the n. Question.
Nope.
Huh? You take a nap? I thought you were saying during lunch to take a nap. You didn't.
I got one.
You got hungry? I mean, that's usually what happens.
You recording?
Yes. The number of reported cases of a gamma virus has been dropped by 70% a year since 2004. There were 1 million reported cases of the virus. What's my transition?
A year.
A year. Transition rule. Okay. What is happening if I'm dropping by 70%? What does that look like as a number? 0.3. Okay, so your recursive formula would look like this. 0.3 times the number that comes previous. Okay, what's my initial population here? 1 million. Remember, that is 6 zeros. What is the explicit formula? So, P sub n. This is what we just did with those last 3 examples. So we need P sub 0 first, which you just told me was 1 million. What's my growth rate? 0.3. Okay. It's 70% low. So it's 0.3 raised to the n. If the present rate continues, how many reported cases of the virus can we expect in 2010? So we're going to use your explicit formula. What's going in for n? Why 6? I started in 2004. I'm now in 2010. So I raised this to the 6th power to get my answer. Should this be going up or down? Down. It's dropping by 70%. This should go down pretty fast. You should really end up with a kind of a small number compared to a million.
729.
729 reported cases. Anybody that's interested in going into medicine and that kind of a field and looking at, how viruses attack people and how we get rid of stuff.
This helps.
This helps. You will see this again. Anything medical field, you're going to see this again.
You don't have to use it to count all that money,
Okay. Take a look at number 1 on the next page. They tell me. Stop having conversation. My time. P sub 0 is 8. R equals 1.7. They want us to write the explicit formula first and then solve for P sub 16. So my formula looks like what?
8.
8.
1.7.
1.7 raised to the n. Geometric is so much easier than arithmetic. Okay? The formulas are wonderful. We're trying to find P sub 16, so I need 8 times 1.7 raised to the 16th power.
$38,900. Oh.
928.95. Okay. Number 2. P sub n equals, what number do I start with?
1,000.
1,000. 0.9 raised to the n. So now I need to plug in what?
11.
11.
$313.81.
Perfect. Okay. Number 3, we have initial population of 20,000 with a 20% increase. What is the 5th generation? P sub n equals 20,000.
1.2.
Good. My growth rate is a 20% increase. So 1.2 raised to the n. And I need my 5th generation. So we're plugging in 5.
Um, 49,766.4.
766. Okay. And finally, my initial population is 85,000 with a 15% decrease with each transition. So P sub n equals 85,000. 0.85. 15% less than 100 is 85%. Written as a decimal is 0.85. Raised to the n. So we've got 85,000 times 0.85. And I'm trying to find the 7th generation. So we raise this to the 7. We said 27,249 point what? 05. Perfect. Question. This is why I do arithmetic first, because usually when we get to this point, you guys are like, oh, I can handle this. Okay. This is pretty easy.
So yesterday what you meant, that's as hard as it gets. It's like you make the whole unit, right? The whole chapter. That's it.
Okay. Your population grows according to an exponential growth model. The initial population is 11, and the common ratio is 1.25. Find P sub 1. What would I plug into my calculator to find P sub 1? 11, 1.25, raised to the first. You really don't need to plug that in, the raised to the first part. You would just take 11 times 1.25, because raising something to the first does nothing. And what do we get here? 13.75. Part B, all you would change up is what?
The 9.
Raise it to the 9th. So 11 times 1.25 raised to the 9th. 81.96. And then finally, part C, all they want is your explicit formula. What did you use to do this? 11 times 1.25 raised to the Who would have thought they would want you to come up with a formula first, then plug stuff in? Number 2, a population grows as an exponential model. P sub 1 is 9 and P sub 2 is 12. We need our common ratio first. How do I get that? 12 divided by 9. 1.3. said?
Yeah, it's a whole bunch of threes. So I just put 3.
1.3 repeating. When it does that, I would change it to a fraction when you have the repeating. So 4/3, okay? That is my suggestion to you because when you round it, you kind of stop it from continuing. So I would change it to a fraction. Now I need to find P sub 0. Okay, so if I would multiply 9 by 4/3 to get P sub 2, how would I work backwards to get P sub 0? Divide. Okay, so take 9 and divide it by 4/3. Don't forget to put your 4/3 in parentheses. $6.75. And now we can find P sub 11. We have all of our information to do our formula. So my formula looks like what? What's my starting value? 6.75. That's what we just solved for. We solved for P sub 0. Times 4/3. And I'm finding P sub 11. So we raise it to the 11.
And it equals
159.81.
159.8. 3 more at the bottom of this page, and we've got 6 on the other page. No,
We're done.
and we're done. Okay. I've got to give you the sum formula for geometric. Okay, crime in Pleasantville is on the decline. Each year, the number of crimes committed decreases by 20%. Assume that there were 400 crimes in 2000. Let P sub n denote the number of crimes committed in years after 2000. I'm not worried about the recursive. We're going to skip that. Write my explicit description, my explicit formula. So this is P sub n equals Pee-wee. What's my first number? How many crimes do we start with?
2,000. Wait,
400. 400.
Y'all's name Pee-wee? Yeah. Okay. Pee-wee, if we're decreasing by 20%, so we're going 20% less than 100, what percent is that? 80, written as a decimal is what? Perfect. He's so quiet over there. I have to make sure he's with us. Crimes are going to be committed in 2006, or no, 2006. Ugh. 2006, yeah. We're all ancient now. We did, buried in the ground. Okay, what do we plug in for n? 6. So 400 times 0.8 raised to the 6. How many crimes are being committed then? Okay, 104 point, you said 86. Okay. You can't have 0.86 of a crime, so rounded, approximately 105 crimes. I've got one more formula to introduce you to. Again, this formula is given to you on your test. Okay? So, as long as you know what everything means, you are golden. Okay, here it is. Let me see which one they actually give you on your test. I think it's the second one, because I want to use the one that they're actually going to give you. Whoop. Yeah, they give you the second one. Okay, so we're going to focus on the second one. Both do the same thing, but we're going to focus on the second one. Okay. A sub 1 is still your first term, just like in arithmetic. What does R represent? Your constant weight. or constant ratio, however you want to describe it. And N is the number of terms. Okay, so just like we got a new formula with arithmetic where it would take all your numbers and add them together, that's what this one does for geometric. Okay. So let's do this. What is my first number in number one? 8 times 1 minus. What's my constant rate? Do 12 divided by 8, and that gives me what? 1.5. Okay, so this is 1.5 raised to the what? How many terms are there? 6. 1, 2, 3, 4, 5, 6. Raised to the 6th divided by 1 minus 1.5. Literally, in your calculator, exactly the way you see it. 8. Open parenthesis. 1 minus 1.5 raised to the 6th. Close it. Divided by. Open. 1 minus 1.5. And we get what? 166.25. As long as you can plug the numbers in and you can plug them into your calculator, to do. Find the sum of the first 100 terms with the first term of 1 and the common ratio of 2. So my formula looks like what? 1 minus 2 raised to the divided by 1 minus 2. What do we get? 1,023.
You said 1,000.
Number 3, I want to go over because it looks a little bit different here. Guess what? They basically give you your explicit formula. So, looking at this, what's my first term? 4. What's my constant rate? 0.3. Okay? What value am I going up to? 11, but be careful. This is P sub 0, this is P sub 11, so how many terms do I have there?
11.
12. Divided by 1 minus 0.3. Because remember when we did the arithmetic, if I went from 0 to term 999, there was 100 terms there. Same thing here. I started term 0 and I go to term 11, so there's actually 12 terms. Because 1 through 11 makes 11 terms, and that 0 gives you 12. What do we get here? Cricket, 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 cricket. 5.71. Is this stuff all that boring? Is it so easy that it's boring?
Mm-hmm.
Okay, let's fly through this then. This one, what do I start with? 5. What's my constant rate? 3 raised to the 8. 1 minus 3. Your answer here should be 16,400. Bam. We've got 3 more at the bottom, unless you would like to do those on your own.
Yeah.
That's fine.
You're saying.
You're just gonna go to sleep? I mean, like the rest of the class?
I tried that. I don't want to shoot.
Look at your one.
That just means I'm off limits. I don't care. They have no reason to ask a question.
Oh.
Yeah, go get some water, Miss Smith.
Huh?
That was water.
Okay.
Actually,
Okay. The last one. I definitely just want to go over the last one. You already know how to do 5 and 6. Let's talk about the last one real fast. An imaginary infectious disease called the X virus has no known cure. It'll kill you. The first appearance of the X virus occurred in 2005, which is year 0, when a total of 5,000 cases were reported. The virus will spread at a 40% annual rate of growth. How many estimated cases will there be in the X virus over the 10-year period? Okay, so we're trying to find the sum. What is my starting number? 5,000. What is my constant rate? 1.4. It is growing, so it's higher than 100. So 1.4. How long is this happening for? 10 years. Divided by 1 minus 1.4. And you should get a grand total of 349,068 cases. A lot of dead people. Lots and lots of dead people.
I'm kind of on them, sure.